The Little Ice Age was triggered by an unusually warm period, according to a new study. A sudden change from very warm conditions in the late 1300s to unprecedented cold conditions in the early 1400s, only 20 years later. So what happened? This is by University of Massachusetts Amherst on phys.org on Blended Reality. New research from University of Massachusetts Amherst provides a novel answer to one of the persistent questions in historical climatology, environmental history, and the earth sciences. What caused the Little Ice Age? The answer we now know is a paradox, which was warming. The Little Ice Age was one of the coldest periods of the past 10,000 years, a period of cooling that was particularly pronounced in North Atlantic region. This cold spell, whose precise timeline scholars debate, but which seems to have set in around 600 years ago, was responsible for crop failures, famines, pandemics throughout Europe, resulting in misery and deaths for millions. To date, the mechanisms that led to this harsh climate state have remained inconclusive. However, a new paper published recently in Science Advances gives an up-to-date picture of the events that brought about the Little Ice Age. Surprisingly, the cooling appears to have been triggered by an unusually warm episode. When lead author François Lapointe, postdoctoral research and lecturer in geosciences at University of Massachusetts Amherst, and Raymond Bradley, distinguished professor in geosciences at UMass Amherst, began carefully examining their 3,000-year reconstruction of North Atlantic sea surface temperatures, results of which were published in Proceedings of the National Academy of Sciences in 2020, they noticed something surprising: a sudden change from very warm conditions in the late 1300s to unprecedented cold conditions in the early 1400s, only 20 years later. I support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Using many detailed marine records, Lapointe and Bradley discovered that there was an abnormally strong northward transfer of warm water in the late 1300s, which peaked around 1380. And as a result, the waters south of Greenland and the Nordic Sea became much warmer than usual. And Lapointe notes no one has recognized this before. And we have to correlate this to what's happening today with the Arctic melting and a lot of warm water around Greenland and the north, of course. This is exactly what's happening today. Normally, there was always a transfer of warm water from the tropics to the Arctic. It's a well-known process called the Atlantic Meridional Overturning Circulation, AMOC for short, which is like a planetary conveyor belt. We know it basically as the Gulf Stream, the current. Now, typically, warm water from the tropic flows north along the coast of northern Europe, and when it reaches higher latitudes and meets colder Arctic waters, it loses heat and becomes denser, causing the water to sink to the bottom of the ocean. This deep water formation then flows south along the coast of North America, and it continues on to circulate around the world. But in the late 1300s, AMOC strengthened significantly, which meant that far more warm water than usual was moving north, and that in turn caused rapid Arctic ice loss. Over the course of a few decades in the late 13 and 1400s, vast amounts of ice were flushed out to the North Atlantic, which not only cooled the North Atlantic waters, but also diluted their saltiness, ultimately causing AMOC to collapse. It is this collapse that then triggered a substantial cooling. Fast forward to our own timeline. Between the 1960s and 80s, we have also seen a rapid strengthening of AMOC, which has been linked with persistently high pressures in the atmosphere over Greenland. Lapointe and Bradley think the same atmospheric situation occurred just prior to the Little Ice Age, but what could have set off that persistent high-pressure event in the 1380s? The answer Lapointe discovered is to be found in the trees. Once the researchers compared their findings to a new record of solar activity revealed by radiocarbon isotopes preserved in tree rings, they discovered that unusually high solar activity was recorded in the late 1300s. High solar activity. Such solar activity tends to lead to high atmospheric pressure over Greenland, the North Pole. Now, at the same time, fewer volcanic eruptions were happening on the Earth, which means that there was less ash in the air. A cleaner atmosphere meant that the planet was more responsive to changes in solar output. Hence, the effect of high solar activity on the atmospheric circulation in the North Atlantic was particularly strong, Lapointe explains. Lapointe and Bradley have been wondering whether such an abrupt cooling event could happen again in our age of global climate change. They note that there is now much less Arctic sea ice due to global warming, so an event like that in the early 1400s involving sea ice transport is unlikely. However, they said, we do have to keep an eye on the buildup of fresh water in the Beaufort Sea, which is north of Alaska, which has increased by 40% in the past 2 decades, the buildup of fresh water. Its export to the subpolar North Atlantic could have a strong impact on oceanic circulation, Lapointe explains. He says also persistent periods of high pressure over Greenland in summer have been much more frequent over the past decade and are linked with record-breaking ice melt. Climate models do not capture these events reliably, and so we may be underestimating future ice loss from the ice sheet, with more fresh water entering the North Atlantic, potentially leading to a weakness or collapse of the amok. The authors conclude that there is an urgent need to address these uncertainties. This by University of Massachusetts Amherst via phys.org on Bended Reality. Please leave your comments and thank you for your support.